when things don't factor nicely, what else can we do? Quadratic formula, and we'll go over that in a second. But we can't just skip completing the square, because when we get into graphing and transformations, we will have to use this strategy. So I'm going to go ahead and show it to you now, so that when I bring it up again later, we've seen it before. So in completing the square, your quadratic has to have a coefficient of 1. So if you have a number in front of your x squared, go ahead and divide by that. Second, we want to move the constant over to the other side, so that both terms on the left have an x, the term on the right does not. Then we have to make a perfect square. So if you think about perfect square, if I say x plus 2 squared, that's x squared plus 4x plus 4. If I said x minus 3 squared, we know that means you write it twice and FOIL, right? If I said x plus 4 squared, if you wrote that twice and FOIL, what do you get? Okay, if you did x minus 5 squared, what would you get? Okay, so essentially when we're completing the square, we have these two terms. We're trying to figure out what this number should be. And so if you think backwards, this negative 10 came because I had a 5 in each parenthesis, right? So if you took that and divided by 2 for the two parentheses, that gives me the 5, and the constant came from 5 squared. So it's half this middle term. So 8 divided by 2 is 4. 4 squared is 16. 6 divided by 2 is 3. 3 squared is 9. 4 divided by 2 is 2. 2 squared is 4. So we're finding the constant that we need to add so that this would factor nicely. But it's an equation. So if you add it on one side, you add it on the other as well. All right, then we made a perfect square so we can factor it. So then we'll factor, and then we can solve it using the square root method. So let's take a look at one. If I were trying to factor this nicely, is there anything that multiplies to negative 14 and adds to negative? No. So, we are going to complete the square. It needs to be a 1x squared, and it is. Second step says you isolate the constant. So I'm going to add my 14 over, I'm going to leave a little space there. Okay, now, here comes the part where we make a perfect square. So we have to take that middle term. That's a negative 4. We have to think, if it's a perfect square, there were 2 of these parentheses. So we divide it by 2. And then what do we do to that number? Square it. So negative 4 divided by 2 is negative 2. What's negative 2 squared? So we add 4 to this side, which means we have to add it to the other side. Does everyone see where I got my 4? Then we need to factor. What two numbers multiply to 4 and add to negative 4? Negative 2 and negative 2. So I could write that as x minus 2 squared. Equals 18. Notice, negative 4 divided by 2 was negative 2. This is negative 2. Whatever that number was before you squared it is what's going to be here. If I told you to solve for x now, what would you do? Square root. When you add that, you need a plus and minus. So x minus 2 equals plus or minus. How would I break down 18? Yeah. 9 and 2, so square 9 is 3. Can't break down the radical 2. Then final step to get x by itself, add over the 2. So it's 2 plus and minus 3 radical 2. A lot of times when you do this, you are going to get radicals or i's in your answer. If you're getting two nice numbers, that means the original problem could have been factored nice. Okay, but if the original can't factor nicely, you're going to get an uglier answer like this. Do you guys remember doing this last year? Good. Let's try another one. Okay. What do you notice about this one? So we need to start out dividing everything by 9. So that gives me x squared. 12 over 9, we have 4/3 x. Plus 9 equals 0. Oh, yeah, thank you. All right. Now what do we have to do? Okay, we have to get the x's by itself. So if we want to move this 1 over, we can subtract it. That's x squared minus 4/3 x equals 1. Okay, this one is maybe less obvious because of the fraction, but let's think. Oh my goodness, I am struggling. It's the end of the day. It's Friday afternoon. I'm tired. Okay, what do we do now? We have to do half of that number. So it's a negative 4/3. You can either think of it as dividing by 2 or times 1/2. What do we get? That's negative 2/3. Okay? But what do I do with this number? Square it. So when you square, it's just like squaring the top and squaring the bottom. So negative 2 squared would be positive 4, 3 squared would be positive 9. So I add 4 9s to each side. Alright, so then when we go to factor this, it was an x squared. Because this was a minus, I know I'm going to get a minus. It's a perfect square. What's the square root of 4 9s? 2/3. That was the number we had before we squared it, negative 2/3. Negative 1 plus 4 9s, so negative 9 over 9 plus 4 over 9, negative 5 over 9. Okay, how do you get rid of the square? And when you square root, you do plus and minus. So x minus 2/3 equals plus or minus the square root of negative 5, square root of 9 is 3. Then we add our 2/3 over, so we get 2/3 plus and minus I radical 5 over 3. After I struggled for a bit on that one. Other questions on this? Why don't you guys try one? You want an easy one or hard one? Easy. Medium? Medium? Okay. Let's do divide everything by -4. So x squared minus 2x equals -7/4. Okay, middle term is -2. Divide that by 2 and square it. So -2 divided by 2 is -1. -1 squared is, so I add 1 to both sides. Okay, multiply +1 and add to -2. -1. Okay, -7/4 plus 1. So -7/4 plus 4/4. Square root. Plus and minus. So x minus 1 equals plus or minus. Square root of -3 will be I radical 3. Square root of 4 is 2. Add over your 1, so 1 plus and minus I radical 3 over 2. Is that okay? Alright. Quadratic formula. So the other option when things don't factor nicely, quadratic formula. I don't give it to you in here. This is something that we use a lot, so I kind of expect you to learn at some point. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This works for any quadratic. No stipulations on if a has to be 1 or positive or anything. It just has to be a quadratic equal to 0. So for example, if I said 2x squared minus or equals x minus 4, what would we have to do here? Has to be all on one side. Does it matter which side? Not at all. Do you guys have a preference? Feel safer when everything's on the left? So we can subtract over the x. Subtract and then add over the 4. So 2x squared minus x plus 4. So remember, a is the coefficient of x squared. So that will be a 2. B is the coefficient of x, so that's a -1. C is the constant, so that is a 4. So maybe just plug into our formula. X equals the opposite of b. So if b is -1, the opposite would be 1 plus or minus square root of b, so -1 squared, minus 4 times a, which is 2, times c, which is 4, all over 2a. So -1 squared, -1 times 1, -1 is +1, minus 4 times 2 times 4, 32, all over 4. So 1 minus 32 is -31 over 4. All right, if I wanted to break that up, so that'd be a 1/4 plus or minus. How would I write -31? I'm guessing you probably did quite a few of these last year, quadratic formula. Fairly familiar? Okay.
He's going to be swinging over today.
Okay, perfect. Thank you.
Yes, ma'am.
Alright. Do we need another quadratic example? Quadratic formula? Last thing I want to mention is sometimes we don't even need the entire solution. We just, when we're talking about a graph, the kind of solution matters. Like, is it going to be an I? Or is it a nice number? Do I get the same answer twice? Or do I get different answers? And so, the discriminant can be helpful. Discriminant is just the thing under the square root in the quadratic formula. So in the quadratic formula, we have the square root of b squared minus 4ac. So discriminant is just b squared minus 4ac. So here are the different cases. If b squared minus 4ac is greater than 0, so if we have a positive number, we have the square root of a positive, so plus the square root minus the square root, we get two different real solutions. If you have a negative under the radical, what kind of answer do you get out? When we have a negative, that's when we get i's. So if it's less than 0, we get two different imaginary solutions. And if it equals 0, we get one repeated real solution. Remember yesterday we talked about multiplicities, you get the same answer twice. It's a real number. The only way to get an imaginary is if you have a negative under your radical. But you get the same thing out twice. All right. I just want to do one or two examples of this and then I'm done. Okay? So if I told you on these problems, it will say, did everybody get that down before I switch to my slide? Yeah.
Did you not put the square root under it?
Technically, the square root is not included in the discriminant. It's just the number under the square root. Good question. So typically when you see this, it's just going to say, find the number of real solutions, or find the type of solutions. It's not even asking me what the answer is, just what kinds of numbers am I going to get out. So if I'm doing this, you could certainly do the entire quadratic formula and then tell me at the end, but all we really have to do is the b squared minus 4ac. What's my b? 5 squared minus 4 times a times c. It's 25 minus 12, which is 13. So my discriminant is 13. What does that tell me? Yep, it's a positive number, so that's two real solutions. What if I said x squared plus 3x plus 20 equals 0? So if I want the discriminant, so b is 3, so 3 squared minus 4 times a is 1 times c is 20. So I get 9 minus 80, or negative 71 for my discriminant. What does that mean? Okay. So this is my stopping point for today. Do you guys have questions over anything that I've done? There is a handout posted on Classroom, but I want you to listen carefully because I am modifying a bit. On your handout, I 1 through 8. And then